Let's continue to see how should we use the linked list to implement the associative array. So what you see here is the public interface for the linked list implementation. All the member functions should be the same as our array implementation. So we still have the default constructor, copy constructor, assignment operator. So we have two getter function and two setter function. So we still have the keys and the size and clear. So that's what we see here. We already talked about how to implement using the linked list to implement stack and the queue. So that's why you can make your choice. You want to have one first node only to point to the first node. So this way we kind of using the stack implementation. Or if we want to have the first node and the last node, so you can keep tracking the sequence, or we say the order when we try to add the key to the associative array. So that's all your choice. So now we see here, in my example here, I'm only using the first node. So that's why on the other hand, we can see the first node will always point to the last key we add in. Linked list implementation will be easier because we already have the node struct. For the associative array, we just need to add one more value. So that's we need to add one more attribute. That's our key. So then we still have the value. So then we still have our next node. So we see how to implement all the member function for the linked list. The first one, default constructor. Right, so then you just need to initialize our first node equal to 0, size equal to 0. For the copy constructor and the assignment operator, they will be the same as when we implement the stack. So now, again, let's start with the getter function. So the first thing we see, how should we implement the operator, square bracket operator getter function? If you remember, here is our getter function when we using for the array implementation. So no matter getter function and setter function, we know we have an for loop inside the getter function and setter function to searching for the key. So in the array, we're using the for loop I equal to 0, I less than cap. But how about the linked list? Right, the linked list, we still have the for loop, right, to access each element. But this one will be different because we were using a node pointer. So this node pointer, we will start from the first node. So then when the first node equal to 0, so that means our condition is P. As long as P is not equal to 0, we continue. So your P will equal to the P next. Right, so the same thing, we still have a for loop for the linked list. So in this getter function, right, so we just need to using a for loop to check. So if our P, so in this P node, if the key equal to the key, right? So the key we passing by. If we find the key, for the square getter function, we just need to return the P. So this P is pointing to the node we are looking for. So we return the P value. Otherwise, if we don't find that, right, so very easy, we just do the return V. Because we do the copy. So if you have the copy value, so that you can just give them the default value. So they will copy using the copy value for the default. Yeah, so that's our getter function for the operator square bracket getter. So now the same thing. How about the next getter function? How about the content key? Right, so let me use this one to continue. So the content key will be the bool return type. So then the same thing, we will pass in the key. But here our array, our function name is contents key. Okay, so for this contents key getter function, how we will do? Right, we still have the for loop. We still compare the p key equal to the key or not. If that's right, you find the key. Yeah, we just return true. Otherwise, if we didn't find that, we finish the for loop, we return false. So that's our toGetter function. So how about the setter function? So the setter function, right, we have the square bracket setter and we have our delete key, right? Okay, good. So we do the delete key first. So delete key is a void function. So if we want to delete key, so this delete key, you pass in the key, correct. We still trying to do is we're using a for loop. But the different thing is, if we find the key, we will remove that key. But if we don't find the key, we just do nothing. So that's why here we just remove all the return. Because one thing is, the delete key only when we find the key, we try to delete that node. Otherwise, we do nothing. Do you still remember how to delete a node? Right, so after you find that, right, so you just need to delete that node. So to delete the node, you need to have the temp node. Okay, so this temp node equal to P. So then we have our P. Let's restart our delete key. So our delete key, we still need to use a for loop. But don't forget, when we find the node, right, we need to remove that node. And we need to have the previous node point to the current node next. So that's why here actually we need to define not only P, we need to have the priv as well. And also one thing is, if we find the key, right? So if we find the key, actually our for loop still will continue. So that's why earlier in our example, because we return some value from the after we find the match. So that's why we don't need to worry, your for loop will continue. So that's why here, since we don't return anything, so when we find the key from the target node is equal to the key, we need to break from our for loop. So then after we break from the for loop, right, so then we can start trying to delete that key. So that's why here we will have, after we leave the for loop, right, remember we possibly have two situations we will leave the for loop. One thing is we break. One thing is maybe we never find that key. So that's why you need to have the P. We need to check if the P equal to 0 or not. If P equal to 0, we do nothing. But if P not equal to 0, that means the key is found. So that's why here is really how we will delete the key. So the delete key, since we find that the first thing, don't forget, we have to decrement the size. So then the other one is we need to check. This P actually, we need to be careful if this P is the first node or not. So that's why here inside, if the priv equal to 0, that means the P we find is the first node. So that's why what we need to do is we need to make the first node equal to 0. So then we have the first node equal to 0. Okay, otherwise, if this one is not the first node, so then we just need to make our priv next equal to the P next. Okay, so after we finish this if statement, so then here before that, after you finish this if statement, so we point the pointer to the correct location. So now we can delete the P. So this one is our delete key setter function. So the next one we will see how should we do the square bracket setter function. So here is our square bracket setter function. So we will return the value reference. So for the square bracket setter function, we still need to start with a for loop. So if this for loop we find the key, so then so we just need to return the P value. So this one will be the same as our getter function. However, if we didn't find the key, so how should we do? So actually now we need to create a new node for that. So that's why if we find the key, you can just return the P value. But if not, so then when we come to here, we need to create a new node. So this new node is node temp. So this temp node will be the new node. And actually we already know the value because you see the key is the key specified here. So then the value, actually we don't know the value yet. So that's we can just give them the default constructor. So then here, because I'm using the initializer, we need to specify everything. Okay, so then actually the node next will be what? So remember, since we're using the first node only, so this new node, the next will be the first node. So this one is our temp node. So this temp node, since your temp node next will be the first node, so that's why here, then our first node will equal to the temp. So when we return, we will just return the first node value. But before that, don't forget, since you create a new node, right? So then before we return, we need to increment our size. So that's the setter function for the square bracket setter. So the last one I want to talk about is actually for the clear or the copy constructor assignment operator. They are all similar to our stack version. But the only thing we didn't have that actually is our keys getter function. So that's finished the keys getter function. So we need to return a queue. Okay, so this queue, the data type will be the same as the key. So this one is our keys function. So this keys function, actually, I don't need any parameter. That's a getter function. So this keys function actually is still the same because we need to go over this for loop. But before the for loop, we need to create our queue. So our queue is, we create a queue. Okay, we just say this one is our key queue. So that's why you still go over the for loop. So every for loop, you have your P node. So then here we just need to keep push the key for each P refer to that key. So after the for loop, right, we just need to return this key queue. So this one we need to be careful if you use the stack implementation way to have only have the first node. So actually this first node is pointing to the latest key they've been added. So this key queue, the order for the key, they will be the reverse order. So on the other hand, the first one in this queue, they will be the latest key they will add in. So this one is our linked list implementation for our associative array.